All right, this is lesson 4. It's going to be on shifting, reflecting, and stretching graphs. And I just made the executive decision that stretching graphs is going to be a separate lesson. So we are just going to work on shifting and reflecting, okay? So first off, we got to look at some parent functions. So some functions that we just kind of have to start recognizing is our constant function. Constants are straight lines, okay? Again, it doesn't have a slope. It's not moving up or down. Whereas we may have just an identity function. F of x equals x, okay? It's just going to be our kind of like basic slope formula, okay? We also have an absolute value function, which looks like a v. So again, this is important that we call these parent functions, and in order to determine what is happening to them, we have to know what the parent function looks like in the first place. We have f of x equals the square root of x. So our square root is kind of a curve. Okay, and remember, we don't have negative square roots. So that's why it starts right at 0. It doesn't go into the negative. We've got our quadratic, which is x squared. And then we have our cubic function, which is x to the third. So again, these are our base parent functions. So you want to start to recognize the shapes of these. So again, similar is so what we can do is we can take vertical and horizontal shifts. So if you look at a vertical shift that goes upwards, I'm going to add a number additionally to my function. So whatever my function was, if it was f of x, I'm going to add something on the end of it. Whereas if I want to shift it downwards, I'm actually going to subtract it. If I want to shift it to the right, and this is a little goofy, if I want to shift it to the right, I have to take what my function is and I actually subtract it. So you might think, well, usually the right is positive, we add. It's kind of the opposite here. And then if I look at my horizontal shift to the left, again, I have to add what's inside of my function. So let's do an example to kind of help clear it up. So if I take my initial function, let's say x to the third, okay? X to the third is a pretty nice function. And I want to change it by shifting it up, let's say 5 units. I'm going to add 5. And you can see that my graph moves up. I wish it was a different color. And now let's say, hey, I want to take that same function, but instead of shifting it up, I want to shift it down. Well, I'm going to subtract 5 then. So shifting up and shifting down, I can add or subtract. What about if I want to move it to the right? So if I want to move it to the right, I know that I'm going to have to, again, it's opposite. I'm going to have to subtract 5. So if I want to shift it to the right, I got to subtract 5. And very similar, if I want to shift it to the left, I got to add 5. So we can see how our function moves. Now, again, what we're building up to is, hey, I want you to add, I want to shift it to the left 5 and also move it down 7. So you can do multiple things at once. I can say, hey, I'm going to shift it to the left 5. I'm also going to shift it down 7 units. So I've got another cool graph to look at. So you can see here, hey, I've got this original function, the red one, f of x equals x squared plus sine 3x. Okay, that's our parent function. So let's say k, notice k is on the outside. So again, if I were to add it, if I'm adding k and it's positive, it's shifting up. As soon as k becomes negative, notice, okay, it starts shifting. Here it's even. Now it starts shifting down. I'm shifting down. And I can also do that. Again, h is inside my parentheses. So again, once h is positive, it starts it says x minus 3, x minus 5. So again, that shifts it to the right. And then when h becomes negative, think about x subtracting a negative number. Subtracting a negative is really adding. So it'd be like x plus 7 would shift it to the left 7. So that's another way that we can kind of look at, this is a much more complicated function, but again, the rules are the same, how we can shift them. We also got to talk about reflections, okay? So again, reflecting in the coordinate axes. So if I want to reflect in the x-axis, again, I have to take my function and make it negative on the outside. That's going to flip my function. Whereas if I wanted to reflect it in the y-axis, I would have to take whatever my function is and inside of my function make it negative. So we can do an example like that. Okay, so let's see here. Let's take Desmos. Let's get our blank graph. And let's take x squared. So our parent function is x squared. I want to shift it, or I want to reflect it in the x-axis. So I'm going to, again, looking at my rules, I'm going to make the whole thing negative, and it gets flipped over the x-axis. Well, what if I wanted to do flip over the y-axis? Okay, let's take our square root function of x. Again, this is what it looks like. And then to flip it, I need to take the square root of negative x. And now it is going the other way. So again, that's an example of how you can flip following our rules. That's how we would flip our graph. And the fancy word for flip is called reflection. So again, what is the next step from here? Well, I might ask you to come up with an equation. So again, we're going to compare our equation to the square root function. So if I were to have my graph, and I'm going to say that I'm going to use the square root function. So again, I'm just going to kind of eyeball it and draw it out. It looks something like this. It goes on forever. F of x equals the square root of x. We kind of already talked about it, but if I were to say, hey, I want to do g of x equals negative square root x. Again, that would be a reflection in the x-axis. So again, I'm going to draw the same picture, but it's going to be underneath. Okay, it's flipped over the x-axis. Whereas, like we kind of just talked about, we did this one on Desmos. Say I've got h of x, but I wanted to make whatever my x's were negative on the inside. Well, that's going to be a reflection across the y-axis going this way. And then we can kind of, again, combine and keep our rules where we might say, hey, here's, let's call it k of x equals negative square root x plus 2. So again, going back to up here, because it's a plus inside of my function, I know it's going to shift to the left. And then because it's outside, I know it's going to flip over the x-axis. So I'm going to move it to the left 2. So I'm going to move my parent function to the left 2 and then flip it over the x-axis, which would bring it down like this. So it looks something like that. We can go ahead and double check our answer. So we've got the square root of x as our parent function. We said negative square root x plus 2. And you can see it looks like we did it correctly because it's going to move over. All right, so again, the key is you got to understand your parent functions, and then you have to look at what is happening. Is it shifting up or down? Did it get reflected? And you can